Now, after studying the higher order derivatives, higher order differential equations introduction, and then moving towards the second order linear differential equations with constant coefficient and constant term, we in this topic analyzed and found out the values of roots, that is the values of r, which were taken to be as R1 and R2, and both R1 plus R2 was equal, the sum of R1 plus R2 was equal to minus A1, and the product of R1 and R2 was equal to A2. Now what we will do now is we will study the cases of characteristic roots. What are the cases of characteristic roots? We will study the roots in a way that the value of, there are three different cases of characteristic roots. The first case will be a case where the value of R1 and the value of R2 both are different, that is they are both distinct values and they are real values. These roots are distinct and real. As you know that the formula that we studied for the second higher order differential equations in case or in terms of evaluating the values of distinct roots was equal to minus A1 plus minus square root of A1 square minus 4A2, okay, A1 square minus 4A2, and the whole was divided by 2. Now this formula gives us the values of both R1 and R2. Now the first case is the case of distinct and real roots. R1 and R2 both are distinct and real numbers only if A1 square is greater than 4A2. If the value of A1 square is greater than 4A2, what we will have? We will have a positive value within this square root term. That is, if A1 square is greater than the value of 4A2, then we will have some positive number. And if we have some positive number, this positive number will be added with minus A1 and it will be subtracted with minus A1, and both divided by 2 will give us two different values. Now let us study the case of distinct and real roots with the help of an example where we have a question where the second order differential equation is, the second order derivative is y prime of t, its coefficient is equal to 1 plus y, the first order derivative is y prime of t, again its coefficient is also equal to 1 minus 2y is equal to minus 10. These are the two coefficients, coefficient 1 and coefficient 2, A1, A2, and this one is equal to B. Now the value of A1 over here is equal to 1. The value of A2 over here is equal to minus 2. And the value of B is equal to 10. Now when we are solving the higher order linear differential equations or second order differential equations, what happens is that we will take this whole term equal to 0. Now the coefficient over here is equal to 1. The coefficient with the first order derivative is equal to 1. Therefore, A1 is equal to 1. Coefficient with the second order derivative is equal. The coefficient with no derivative is equal to 2, and this coefficient is referred to as A2. Now the value or the term on the right hand side of the equation is always referred to as B. Now if we solve this question, that is if we take it as R1 comma R2 is equal to, now what is the value of minus A1? A1 is equal to plus 1. Assigning a negative sign with it, we get minus 1, okay, plus minus. Now we have a square root sign and we will write the value of A1 square into it, that is 1, the whole square, minus 4 into a2. The value of a2 is equal to minus 2. The whole is now divided by plus 2. This 2 is the formula 2. That is, we have not taken it from any coefficient or any other term, rather it is the formula value. Now R1, R2 is equal to minus 1 plus minus square root of 1 minus minus 8. Now what do we mean by the values in this square root term? It is showing us that it is clear that 1 is greater than minus 8. If the value of a1 square is greater than 4a2, then what will happen is that the result of this whole solution will yield us two distinct roots which are also real numbers. Therefore, R1, R2 is equal to minus 1 plus minus, okay. Now 1 minus minus is equal to plus, so therefore 1 plus 8 divided by 9. As it is clear now, the solution is possible over here. Therefore, R1, R2 is equal to minus 1 plus minus square root of 9 whole divided by 9. The whole divided by 2. Over here we will have 2. Okay. Now our next step will be R1, R2 is equal to minus 1. Standard form of taking the square root is we will take its positive value. The square root of 9 is equal to 3. Therefore, minus 1 plus minus 3 divided by 2. By solving it, what we will get is we will get two different values. That is, for R1, we will have minus 1 plus 3 divided by 2. Basically, we take the value of plus for the first root and then we take the value of negative sign with the for the second root. Therefore, minus 1 minus, okay, over here we will have 3, 2. Minus 1 minus 3 divided by 2. By solving both of them, this is R2. Now, by solving both of them, we will get R1 is equal to, now 3 minus 1 is equal to 2, therefore 2 by 2. R1 is equal to 2 by 2, cancel both of them. Therefore, the value of R1 is equal to 1, which is a real number. And R2 is equal to minus, okay, is equal to minus 4 divided by 2, which is equal to minus 2. So, we have two different roots. One is R1 and one is R2. The value of R1 is equal to 1 and the value of R2 is equal to minus 2. These both are real numbers. Therefore, when we are dealing with the case of when we are dealing with case 1, that is case of real and distinct roots, then the value of a1 square should be greater than 4a2, and by solving the square root having the value of a1 square greater than 4a2 will yield us two roots which are real and they are both different from each other. Through solving this question, we got similar situation or similar answer for our roots as well. Why? Because a1 square is greater than 4a2 in this case. Now the roots of distinct real numbers, therefore, in this case, in this particular case, the values R1 and R2 are different. So now our value of YC will become YC is equal to A1 e raised to power R1P plus A2 e raised to power R2P. Okay, as the roots are distinct and real numbers, so we can find out the complementary function for that equation to be yc is equal to a1 e raised to power r1t plus a2 e raised to power r2t. We will substitute the values of r1 and r2 for both the roots. We will get yc is equal to a1 e raised to power. The value of r1 is equal to 1. We will get 1t plus a2 e raised to power minus 2t. Okay. Therefore, yc is equal to a1 e raised to power 1t plus a2 e raised to power minus 2t. Now, why can we write this equation in this form? Because the roots are distinct real numbers. These both roots are distinct real numbers. Therefore, yc is equal to a1 e raised to power 1t plus a2 e raised to power minus 2t. We can also find out the value of yp for this equation, as we know that the value of b for the equation given to us was equal to minus 10. Why was it minus 10? Okay, let's go back to our question. We can see in this question, we have the value of b equal to minus 10. That is, the value on the right hand side will always equal to minus 10, is always equal to b. Therefore, yt is equal to, we know it is equal to b divided by a2. So if yp is equal to b divided by a2, therefore yp is equal to minus 10 divided by minus 2. And by solving it further, we know what will happen is that the negative signs will cancel out for each other, and we will get the value of 5. Y is equal to yc plus yp. Therefore, if we want to study the time path for this equation, we get y is equal to a1 e raised to power 1t plus a2 a1 e raised to power 1t plus a2 e raised to power minus 2t plus 5. Now, to definitize the constants a1 and a2, what we will do, we will definitize both the constants a1 and a2. There is a need for two initial conditions. Suppose we have y of 0 is equal to 12. Now we want to definitize a1 and a2. Therefore, for that, what we will do, we will have two initial conditions. Y of 0 is equal to 12 and y prime of 0 is equal to minus 2. It means that when t is equal to 0 and then yt is equal to 12 and y prime of t is equal to minus 2. If the value of t is equal to 0, that is, t over here will also become equal to 0 and t over here will also become equal to 0, then what will happen is that yt is equal to 12, okay, that is t is equal to 0, y 0 is equal to 12, and by taking its second derivative we get y prime of 0 is equal to minus 2. This is the first derivative basically. Y 0 is equal to 12 and the first derivative of the function where t is equal to 0 will become equal to minus 2. Now we put t is equal to 0 in equation A. Okay, which one is equation A? Equation A is basically referred to this equation. Now we will put t is equal to 0 in equation A. Therefore, what we will get over here is y of 0 is equal to y of 0 is equal to a1 e raised to power 0 plus a2 okay e raised to power minus 2 into 0 plus 5. What will happen over here is that e raised to power 0 is equal to 1. Again, e raised to power 0 is equal to 1. Therefore, y of 0 will become equal to, what we will get over here is y of 0 is equal to a1. Why will a1 come over here? Because e raised to power 0 is, this value will become equal to 1. So therefore this will become a1 plus, again, minus 2 multiplied by 0 is equal to 0. E raised to power 0 is equal to 1. Therefore a1 plus a2 plus 5 will be the value of y of 0. And we know that the value of y of 0 is equal to 12. Therefore 12 is equal to a1 plus a2 plus 5, a1 plus a2 plus 5, and we are definitizing both the constants. Therefore, what happens is that we will bring 5 on the left hand side of the equation. 12 minus 5 is equal to 7. 7 is equal to a1 plus a2. Okay. Now, this is the value of a1 plus a2. The sum of a1 and a2 is equal to 7. Now, what happens next is, now we have another important step over here, which is very important to solve, and therefore we get is, what we get is, now we get the first order derivative of the function, that is y prime of t is equal to a1 e raised to power t. Okay, I'll do one more thing. Let's finish our question at this particular point. Let it be equation number 1. In the next lecture, okay, we know that the value of yt is equal to yc plus yp. Again, we write it as y is equal to a1 e raised to power t. I'll write the equation again so that when we find out the first order derivative, it is easy for you people to understand how I have taken the derivative. y1 is equal to a1 e raised to power t plus a2 e raised to power minus 2t. Okay, and the next value over here we have is equal to 5. Now what we have to do, we have to take the derivative, that is first order derivative. Y prime of t is equal to, why are we taking this derivative? We can see that over here we are given the value of y prime of 0 is equal to minus 2. Therefore, first of all, we have to take the derivative of this function, and then we can find out the value of y prime of 0, that is equal to minus 2, and through which we will solve this for the whole equation. So therefore, y prime of t is equal to, now a1 is constant, we will write it as it is, a1. Then what happens is e raised to power t will be written as it is. This is exponential function rule, and the derivative of t is equal to 1. a1 e raised to power t into 1 plus the next one is a2 is also equal to constant. We will write e raised to power minus 2t as it is. Okay, wait. And then the derivative of minus 2t will become equal to minus 2 plus the derivative of 5 is equal to 0. Now therefore y prime of t is equal to, y prime of t is equal to a1 e raised to power t plus, now we have minus 2 also over here assigned with this function because of taking the derivative, minus 2 a2 e raised to power minus 2t plus 0. Okay, now what happens next is let t is equal to 0. Let t is equal to 0. Then we have y prime of 0 is equal to, now a1, okay, e raised to power 0 where minus 2, because plus minus is equal to minus, minus 2 a e raised to power, again what we will get over here is minus 2 into 0. Whether we have e raised to power 0 or e raised to power minus 2 into 0, both will yield the value of e raised to power 0. And we know that clearly that e raised to power 0 is equal to 1. Therefore, y prime of 0 is equal to a1 minus 2a2. Okay, we have not written 2 over here. a1 minus 2a2. This is the value of y prime of 0. What next? What next? We have now y of 0 and y prime of 0. We know that, okay, let's do one more thing. We also know that y prime of 0 is equal to minus 2. Substitute the value of minus 2 in this equation. We get minus 2 is equal to a1 minus 2a2. Okay, let it be, or name this equation as, let us name this equation as equation number 2. Okay. Now subtract equation 2, that is this equation, okay, from this equation, that is equation number 1, where 7 is equal to a1 plus a2. We have now two equations. One is minus 2 is equal to a1 minus 2a2, and the other equation is 7 is equal to a1 plus a2. This is equation number 1. Okay, we can solve both these equations by subtracting from each other. A1 minus a1 will be cancelled out with each other, and also minus 2 minus 7 is equal to minus 9. Clear? Is equal to minus 2a2 minus a2 is equal to minus 3a2. By taking the whole minus 3 to the left hand side, we get minus 9 divided by minus 3 is equal to a2. Now what will be the value of a2? It is very simple. Both the negative signs will be cancelled out with each other. 3 ones are 3 and 3 threes are 9. Oh, sorry, 3 threes are 9. Therefore, the value of a2 is equal to 3. Either substitute the value of a2 in equation number 1 or equation number 2, you will get the value of a1 very easily. Let us say that we know that 7 is equal to a1 plus a2. Okay, so therefore, as you know that 7 is equal to a1 plus a2. So let's substitute the value of a2 over here, that is equal to 3. 7 minus 3 is equal to a1, and therefore the value of 7 minus 3 is equal to 4. We get the value of a1 to be equal to 4. Now we have both the values of a1 and a2. One is equal to, a1 is equal to 4 and a2 is equal to 3. Therefore, to definitize the equation that we had in the beginning, now our final solution will be y of, after definitizing the equation, now our final solution is yt is equal to The value of a1 is equal to 4 e raised to power okay 4 e raised to power 1t. The value of r1 is equal to 1. Then we have plus 3 e raised to power minus 2t plus in the end we will have 5 as well over here. This is how this question is solved. Okay, this is the solution that was required. Therefore, the definite solution of this differential equation is equal to 4 e raised to power t plus minus 3 e raised to power minus 2t plus 5. Now, if you can take y of 0, what happens is that over here, it will become equal to 4. Why? Because if the value of t will become equal to 0, we will get 4 only over here, plus 3 plus 5. 4 plus 3 is 7 and 7 plus 5 is equal to 12. Whereas when we were starting this question, we said that y of 0 is equal to 12. Why y of 0 is equal to 12? We have now a solution for this and we have proved it that y of 0 is equal to 12 because y of 0 is equal to 4 plus 3 is 7 and 7 plus 5 is equal to 12. Hence, it is proved that y of 0 is equal to 12. Now then again, we can write the equation for the second one also, that is y prime of t. We will have to move over here for that. So we have it in the form of this equation. Okay, let's write this one first. Now y prime of t is equal to, again the value of a1 is equal to 4 e raised to power 1t. Okay, then we have minus 2. What is the value of a2? a2 is equal to 3 e raised to power minus 2t. Where is it? Okay, e raised to power, let me just make some space for it, minus 2t. Now this is the second order function. Over here the constant term became equal to 0, therefore there is no constant term. Now if we put this t equal to 0, what we will get, y prime of 0 is equal to, now by putting this t equal to 0 we get 4, and over here what we get is 2 3s is 6, and again e raised to power 0 will become equal to 1. Therefore 4 minus 6 is equal to minus 2. Hence again it is proved that the value of y prime of 0 is equal to minus 0, minus 2, which was given to us over here. Therefore this question is solved completely, and this is the solution for the case of real and distinct roots. The first case has been finished over here. Now after that we will move towards our second case, and in the second case we will not have real and distinct roots, rather we will have real and repeated roots. Therefore now we move towards the second case, that is the case of real and repeated roots. Thank you for listening to me. If you have any questions, you can ask me anytime. Thank you very much.